Okay. Recap. Before the break, we have seen a few equations. So now we're going to apply these three equations. So first equation, V equal to V0 plus ACT. Second equation, S equal to S0 plus V0t plus half ACT square. And the third one, V square equal to V0 square plus ACS minus S0. Now, for the second session, we'll look at one tutorial question. Again, you can see this one in a tutorial question that you can download from the theme files folder. All right. Yeah. Okay, let's see what we have in this question. Now, the car will move from the left in a straight line. Again, we are now in a very basic motion, travel in the straight line. For a short time, velocity is defined in this equation. Okay, define this equation. So V equal to 0.6 t squared plus Tm, so x, where t is in second. The question asks you to determine its position and acceleration when t equal to 3 seconds, and it give you the starting point when t equals 0, your displacement equals 0. So how do we find the position and acceleration using the equation that we learned so far? Okay, now again, recall the recommended steps. First, read the question. Second, draw the diagram, and then put in the x-axis, the origin in your diagram. All right. Yeah, of course, in the answer, you cannot move your diagram, but one benefit when you use PowerPoint, you can have this motion. Okay, so the car moved from the left. So this is your final position. You need to find the displacement from 0 to this final position, because your starting point already given. When t equals 0, the starting point is 0, but you need to find what is this location after a certain time. Okay, and exactly at 3 seconds, what happened to the displacement and acceleration or position, right? So you put in S from 0 to n of position. This one is at t equal 3, and put in your answer, you're finding acceleration and velocity. Remind yourself that all direction to the right is positive. Okay. In your answer, always identify your coordinate system or your reference system. Okay, your 0, where is your origin? Where is your last position? Okay, so this is a 1D dimension problem, one-dimensional problem. If you have motion y and x, then you have 2D. You have x, y, z motion, then you have 3D. We start a very basic motion where only move in straight line. We have one-dimensional problem. So positive to the right, this is what we agree. Position, what information we have? We are given the V equal to this equation. So can you convert velocity in position? What do you think? How do you convert velocity into displacement? Let me try Newton. Newton, are you there? Newton, how do you change velocity into displacement S? What do you think? You use integration or you use differentiation? Newton, are you there?
Sir, is it integration?
How you get, what is the equation, how you calculate velocity? Newton, how you calculate velocity? You take what divided
Change
by
in
what?
displacement over change in time.
Okay, so just now you mentioned you integrate. So when you integrate, you get what? You get displacement, right? So recall the equation for velocity, v equal to ds over dt. So you want to get position, right? You can write ds equal to v dt, and then you integrate. Want to find the position, right? Your displacement of s. You get from your understanding in v equal to ds dt, you rearrange, then you integrate. Okay, you put in the v given in the answer, in the question. ds equal to bracket, this is what given in the question, dt. Okay. All right, try to solve this integration problem. Okay, try to solve this question. I'm going to ask Prem. Okay, Prem, Pranat, and give the answer for this one. Okay, I give you the steps already. Give me the answer for what is your s equal to what. Okay, you integrate your s from 0 to final location s. Again, I just give you a hint. In front of ds, there's a 1 there. And you integrate the whole bracket with t, because you are looking at t, you integrate 0 to t. So what do you get? Okay, Bernard, when you're ready, you can answer. What is the solution for this one? Those watching on the YouTube, you can fast forward to the next answer. Prem, are you there?
So that means the value for the s is 0 for the limit.
What do you understand from this one?
No, for the limit, the value for the ds.
Yeah, you integrate s, right? When you learn about integration, what does the lower limit and upper limit? What does this mean? Your starting point and end point. You start from 0, right? Your car starts from 0, right? Where does your car end? At one position, we call it S. So you integrate this one, what do you get? This one, what do you get? This is not the engineering dynamic question. This is a mathematics integration problem. What do you get if you only look at this? Solving this integration, what do you get? Prem. Sivendra, are you there?
Yes, sir.
Sivendra, help Prem. What do you get if you integrate this part? What do you get? If you integrate from 0 to s over ds, what do you get? You already learned integration, right?
Sir, hang on, sir. 1 minute.
Pranesh, are you there? Pranesh.
Sir, you should get S, right, sir?
Okay. So before you get S, what is the operation? What is the operation? The answer is S, but what is the operation in these integration steps? How you get S?
1 times X with the boundary of S at 0.
Yeah, so what do you get?
You'll get X with the boundary of S to 0.
Yeah, so the mathematics operation is what? There's a mathematics plus minus multiplication or division, right? From here to get the answer of S.
Oh, multiplication.
Are you sure it's multiplication? How you get S? When you integrate this one. Okay? When you integrate this one, what do you get? You get S. 1 will become S. And then you limit from S to 0. Mathematic operation will be S minus 0. That's why you get S. You guys get that?
Yes, sir.
Yes, sir.
Okay, yeah. Now I already explained how to get this one. What is the answer on this side? Again, this is not engine dynamic question, is integration question. Mathematic integration question. This one become what? When you integrate t. If you're not familiar with t, imagine this one is your x. Usually in your mathematics class, you will see y equal to something dx. You just replace t as your x. What do you get?
Sir,
So I got
Yes.
0.2 t cube
Okay.
plus
Plus
t over 2 square. I mean t square over 2.
t squared over 2, correct. Okay, so those don't understand, please go back to your mathematics class or textbook. Correct, just now. Right, so this one, well, this I just be kind to you. I show you the mathematics steps for your first tutorial. All right, after this, I might not show you this one. So this is just a recall from your integration class. So from there, you'll get S equal to 0.2 t power 3 plus 0.5 t squared. Unit meter. Okay, unit meter. The question asks you, what is the position when t equal 3 seconds? In this is the equation. Inside this equation, you only have t. Replace t equal to 3 inside here. What do you get? Nageshwaran, you want to try to answer?
9.9 meters.
9.9 meters. Okay. For this engineering module or for module that I taught in my class, minimum 2 decimal place for your answer. Minimum 2, but maximum 3. Okay, just a remind when you answer your question in test or final exam, minimum 2 decimal place, maximum 3 decimal place. 9.9 meter S. Again, this tutorial question, if you go through, most of the time you need to polish up your integration and differentiation skill that you learn in your mathematics class. All right. You have find your S equal to 9.9 meter. Now we find acceleration. So again, make sure you know the coordinate system, where is the positive, where is the negative. Okay. Acceleration. Let me ask a question. Newton, are you there, Newton?
Yes, sir.
How do you define acceleration? There are two definitions, right, just now. One you use displacement, one you use velocity. So give me one of the definition. How do you define or how do you calculate acceleration?
Change in v equals acceleration times change in t.
Okay, this is one that you use v as a definition. Anyone you can recall, if you want to define acceleration in displacement, can you recall? Anyone, can you recall? You integrate 2 times of, sorry, not integrate, differentiate 2 times of your velocity, you will get d2s divided by dt squared. That is the second definition for acceleration. However, you look at the question, just now you already solved for velocity, so, and the question gives you a velocity, so we straight away use the first definition answered by Newton just now. All right. So acceleration, you use the v equation, you find a equal to dv over dt, rearrange the equation, you get a dv dt, you're given the equation of v, substitute v in the equation, so d over dt times the bracket of the v equation, the 0.6 t squared dt. The next step, again, is the mathematics question, nothing related to engineering dynamics. Okay, let me test. Nageshwaran, you want to try to solve this one? What is the next mathematics operation that you get? What is the next answer that you get if you differentiate this equation? The first one will become, if you differentiate this one over t, what do you get, Nageshwaran? What do you get? This one.
1.2 t plus 1.
Correct. Okay. So this one is just recall your differentiation skill. Huh? So when you differentiate, 2 will pull to the front because 2 minus 1, 2 you pull to the front first, and then this one minus 1. So 2 times 1.6, you get 1.2 t plus 1. Okay, so 1.2 t plus 1. So this is just a extra derivation steps for you. All right, I go it very slow, but in future tutorial I won't do this one for you. Huh? This one you have to write in your answer sheet when it comes to your test 1 or final exam. Right, but in future tutorial question I won't show you these detailed steps. Huh? I will expect you to know from here straight away to this one. Huh? So I will expect some of the detailed step in mathematics I won't show you, but I will expect you to know. Huh? So again, the question asks you what happened when at the time of 3 seconds. You look at this equation, there's only one time there. Substitute 3 there. Nageshwaran, you want to try to solve this one? What is the acceleration at time equal to 3?
2.2 meters per second per second.
Okay. So yeah, you do is 4.6, 4.6 meter over second square. Right? All right, so this is the answer for that one. Any questions so far? Any questions so far? Any questions so far? Just a highlight, this one. Just now, before we break, we go for a 3 equation just now. The 3 equation, they are using constant acceleration. However, this one, you don't need to use the 3 equation straight away. You use differentiation and integration to solve the question. Okay. All right. You can use the equation, but in this case, you need to solve what is your A first. Okay. Yeah, this is just a highlight lah. Why you cannot straight away use the 3 equation just now. Okay. Because your A you need to define in the equation. Okay. Once you get this value, then you can substitute inside the 3 equation there. You can use this value to solve. Okay. All right. Let's go for one more example. Then we call it a day. Is that okay? Is that all right?
Yeah, okay, sir.
Yes.
Okay, one more example.
Yes,
All right. Now this example number 2, let's say we fired a bullet into a water. Okay, it's a water horizon, and we fire a bullet. We do a ballistic test. We fire a bullet, go through the water, and it tells you that you fired downwards. You fired downwards. Okay. With the initial velocity 60 meters per second. Due to drag resistance, the float projectile, the projectile experience a deceleration. A equal to, give you a one equation, A equal to minus 0.4 V cube meter over second square. And then your velocity is in the unit of meter per second. It asks you to determine or calculate the projectile velocity and position 4 seconds after it's fired. Means 4 seconds from this position, it go down, right? So where at 4 seconds over here, what is the velocity and displacement when it fired? So first, look at the question. Second one, draw a diagram. And always ask yourself, where is your origin? So in your diagram, the first step is draw your coordinate system. So this is the horizon, your starting point or starting line, and then label your position, your initial position 0, okay, in your diagram. After that, okay, in this case, to make your calculation more easy, because this is only a 1D problem, so all our calculation we consider going down is positive. Okay, for this example only. Next class or next lecture, you will see that we always assume y going up is positive. But in this case, just to help us conveniently, we assume direction going down is positive. So how do we get velocity? We are given acceleration equation. Again, how you extract acceleration equation, put them into velocity. So you are given initial velocity, which is here, is 60. So initial velocity is v0, 60. Acceleration is slow down, negative 0.4 v power cube. And in this case, we do not consider the effect of gravity. It's just a simple case we only consider the acceleration and initial velocity. Recall the definition of acceleration, a equal to dv dt. Rearrange the equation. You pull the dt to the left, and you can see you having a dv equal to a dt. And then, because the question asks you to solve velocity, so you just integrate the equation. Right? You're given the equation you need to recall. But in the question, it gives you the acceleration value. Okay, acceleration equal to 0.4 v cubed. So you rearrange the equation, dv equal to bracket a dt, and you substitute the value or the equation of a inside the equation. Any questions so far from the first line to second line? Any question?
No, sir.
Good. Okay. The next one, as you can see here, every time you see dv one side, dt one side, the next step should come automatic. You know that the next step will be integration. Okay. Now to do integration, we always put the same term. If you see v, you should put v together. If you see x, the x should put together. If you see t, the t should put together. For example, from step 2, we move the v from right hand side, we put to the left hand side. So these two, bracket, blue color, bracket, and dt is a multiplication relationship. When you move the left hand side, right hand side equation to the left, is inverted relationship. So on this side is multiplication, you move to the left, you become divide. Huh? Multiplication, you move to one side, you become divide. So that's why the third line, you see dv over minus 4v, or you can say divide by the bracket, equal dt. Because in the exam, this one will change. Okay, so just learn about the concept, how we solve this one, the strategy that we use. Okay, the next, from these steps onwards, is the integration scale. There's nothing to do with engineering dynamics. The rest is mathematics. So I do the step for you. Integrate one side, integrate right hand side. Left hand side, the v, you start from initial. Again, be careful. On the equation, that this one, on the far left, all right, you see we start from 60 to v, because the initial velocity is given 60. So always read the question carefully. Don't get tricked by the question. So sometimes you trick yourself, you'll write, it will start from 0 to v. So this is also one of the areas to make mistakes. Just be careful on that. Okay, so we start from 60 to one of the velocity, and t from 0 to t. Again, just a remark for you, I put 1 in front of the dt. So the rest is just integration. Okay, now go and polish up your integration and differentiation skill. So I pull my constant value 0.4 to outside the integration. I will get 1 over v cubed. I do the integration. I'll get, okay, this one is just a rewrite. Okay, so example 2, I'll be very kind to you. I write in the very detailed mathematics steps here, but I will expect you to know in the next class. Okay, I'm very kind to you. So I rewrite this one in term, because I don't like fraction format, I write in the exponential format. 1 over something, if you write in exponential, you can write minus something. Okay, v minus 3, the rest is the same. So you do integration, this one you plus 1 divided by the new exponential. This one also same, you get 1, you integrate, you get t. You get this one from second line to green color. Then you substitute V60 inside here. Okay, this is the equation you get. Okay, I pull the minus 2, minus 0.6, minus, no longer negative there. You get a positive. So V substitute there, 60 substitute there. Be careful, there's a power negative 2 there. This is also one of the careless mistakes in final exam or exam. Student will always forget to carry the negative sign in the calculation. So there's a negative sign there. When you expand the equation, you substitute V, there's a negative 2 there, or sometimes power 2. Negative in here, in this example, is negative 60, negative power negative 2. And this one is what I mentioned just now. When you integrate, you substitute the limit, you take t minus 0, you get t. The rest is just a rearrangement of equation. You get what is V. Okay, rearrangement of equation. You get this form. You arrive at this form. It asks you time equal to 4 seconds. Substitute 4 in this equation. You get your V. Okay, get your V. Substitute 4 in the equation that you derive. You use your calculator. The answer will be 0.559 meter per second. So in the test of final exam, if you only give your answer 0.559 without the unit, full mark, 2 mark for the answer, you only get 1 mark for the answer. Unit always important in this module. Okay, just take note on that. Okay, we have done velocity. Next is position. You have acceleration formula. You want to find position. The position is s. So again, definition of acceleration just now in example 1, I asked one of you. There's 2 definition for acceleration. One you can write in velocity. Another one you can write in the position. All right. So how we do? Okay. So this one. You need to have the direction also. Okay, for this module, just add on. Answer 2 mark, direction 1 mark. So this one combination, you get 3 marks. For this module, because you know that you are dealing with vector, you have magnitude, which is the speed and direction. Okay, so this one 2 mark, this one 1 mark. So don't forget to give me the direction in your answer. You just write arrow, where is your positive direction. Okay, we continue with the same idea to find acceleration. Okay, this one is what you have. Acceleration definition, A equal to dv over dt. You know that this is your velocity just now. You derive from the first steps just now. This is the velocity equation that you derive from here to here. The next step, you want to find position. You just integrate one more time. This one over time, you get displacement or position. So V, definition of velocity, ds over dt, or instantaneous velocity definition will be ds over dt. Rewrite this equation, pull dt to the left, and you have ds over v dt, and you do the integration. Okay, from here to here, then you do the integration. You pull the dt to one side, you get this one. And every time, again, every time you see ds or dt or dx or dy, the next steps you see in this class will be integration. You put the integration sign, left-hand side, because you deal with s from 0 to s, from initial to the final displacement or final position, equal integration or from initial to the time that we study. In this case, 4, but this is a general equation, so we just use t to represent the equation. Again, From these steps onwards is mathematics, your integration skill, you need to polish up a little bit. On these sides, you get s minus 0. This side, you do the calculation for this one and this one. Again, this one might be a little bit complex because this one have an exponential 1 minus 2, but the concept for integration still same. All right, I will just go straight forward. So you'll get this one, and then you integrate from t to 0, substitute the value, you'll get S equation. All right, position equation or displacement equation, or not displacement, position. S is the position. Displacement is delta S. So apologize for the wrong definition. So position is S. So from here to here is integration steps. So at the end, you get one equation for the position. The next steps, you know that the question asks you only at t equals 4. So substitute 4 here and you get your position. Just recycle what we have. Okay, just recycle what we have. Okay. You substitute t equals 4. At the end, you get 4.43 meter. Okay, so this is how you get the answer if the question asks you velocity and position. Okay, with this, we end our lesson today. I end the recording.